Hi everyone, Assalamualaikum. Our group will present about earthwork construction. Will present by Anthony Sandom. Ayu Nurul Ain, Nurul Aqilah will present to Dr. Julaida Kaliwon, and we are from AP2295B.
Hello everyone, my name is Dora. Today, my friends will help Ayu, Anthony and Aqilah to explain to you guys about earthwork. Let's go!
Hello, I am Mr. Frog. Today, I will explain what is the definition of earthwork. Earthworks are engineering works created through the moving or processing of part of the earth's surface involving quantities of soil or unformed rock. The earth may be moved to another location and formed into a desired shape for a purpose. Much of earthworks involve machine excavation and fill or backfill. Earthwork involves the loosening, removal, and handling of earth quantities in the construction process. Earthworks are carried out to provide a level terrace or bench with an even longitudinal slope on which the drainage and cable can be built. The principal activities in earthworks are measuring and calculation of volumes, excavation which includes leveling, cut to cross-fill, U-cut and borrow excavation, loading, hauling and unloading, filling, including spreading and compaction. Every construction project is a unique undertaking. Therefore, planning is undertaken to understand the problems and to develop courses of action. Earthwork construction planning are including review the contract documents, study the plans, plan the work, perform quantity take-off, and determine cost. The earthwork process generally follows a common set of steps. First, we cut off excavate the source material from a borrow or borrow pit. The borrow or cuttings are then transported or hauled from the borrow pit. They are often stockpiled at a location someplace between the borrow pit and the eventual fill. When the material is needed, it is then transported again to the fill area. In some cases, a stockpile isn't needed. If there's not stockpile, the material is transported directly from the borrow pit to the fill area. The fill process itself has 3 steps. First, the soil must be properly placed at the fill site. It isn't just dumped there, each placement called a lift, and the material is no longer borrowed but filled. Second, after the soil is placed, it is usually moisture conditioned by either adding or removing water. By now, you should experience how soil behavior can be dramatically affected by moisture content. You need to understand it is important to compaction. After the fill material is placed and moisture conditioned, it is compacted to increase its strength and reduce its compressibility. This photo illustrates the earthwork process. Here you see the borrow area for an earth dam construction site. The excavator is digging up the borrow material and placing it in a large dam truck for hauling. In the background, you can see a motor grader. Graders are generally used in the placement process, and in this case, the grader is being used to maintain the unpaved haul road. Next picture shows the stockpile area of the project. The dump truck from the borrow area deposits the material in the rock crusher just to the left of this photo. This picture of machinery both crushes the large cobbles in the borrow and sort the material into different sizes. The conveyor transports the material around the size into various stockpiles of different size material from coarse gravel to sand. In the background, you can see a loader filling up a dump truck from a stockpile of sand. This dump truck will transport the sand to the fill area. Here is the dump truck from the previous photo dumping the fill material at its intended location. You'll see at this point the fill isn't placed very smoothly. Before the fill can be compacted, it must be smoothed out to a uniform thickness. Here you see a dozer smoothing out the soil down by the dump truck. In this picture, the dozer actually moving from the right to left to drag the soil on the back side of its blade. The dozer leaves behind a relatively smooth layer of soil called a leaf. It's called a leaf because it sleeves or rises the surface of the field. The thickness of a leaf is typically 8 to 12 inches or 20 to 30 centimeters. If the field material is not at the optimal moisture content for compaction, then it is moisture condition. If the soil is too dry, water must be added. As you can see, there's a water truck spraying water across the field area to increase the moisture content of the soil. If the soil is too moist, it is disliked to expose it to the wind and sun so it can dry out. Here, you can see an agricultural type disc set. The ones used for the construction are essentially the same. They are pulled by the separate tractor. The moist condition can occur before or after the field material is moved out by the dozer. It depends upon the details of the particular construction operation. After the moisture conditioning, the field can be compacted. As you can see, two smooth drum vibratory compactors working in tandem to complete a leaf.
Hello everyone, my name is Mr. Stark. Now I am my friend Miss Lisa here to present about some information about material, benefit, challenges, maintenance and standard of earthwork in construction process. First of all, let's see this video about some information of equipment that used in earthwork process. Let's start from the first equipment that used in earthwork process. This is the bulldozer. A bulldozer is a tractor equipped with a substantiator blade used to push a large quantity of soil, sand, rubber, or other such material during construction or conversion work, and typically equipped at the rear with the claw-like device to loosen densely compacted material. It is usually a crawler tractor. Bulldozer can be found on the wide range of site, mine and quarry, military base, heavy industry factory, engineering project, and farm. Next, we go to the crawler loaders, a machine with a tracker, chassis, and a loader that can be used for digging and moving or loading material. They are versatile component of any fleet, able to perform many tasks. These days, loaders are the most often needed to move heavy material on the construction site. They are well suited for moving wood, chip, sand, rock, and recycled material. Everyone was familiar about this equipment. This is excavator, a heavy construction equipment consisting of a boom, tipper, bucket, and cap on a rotting platform known as the house. All movement and function of the excavator are accomplished through the use of hydraulic fluid with hydraulic cylinder and hydraulic motor. Due to the linear actuation of hydraulic cylinder, their mode of operation is fundamentally different from cable-operated excavator, which use winches and steel rope to accomplish the movement. This is the compact or mini excavator. It's tracked or wheeled vehicle with an approximate operating weight from 0.7 to 8.5 tons. It generally includes a standard backfill blade and features independent boom swing. Other than that, there are many equipment that used for the earthwork in construction process, such as backhoe loaders, skid steer loaders, water grader, trenchers, compactor, and others. Now, my friend, Miss Lisa will request me to explain to you all about the benefits, challenges, and maintenance in earthwork process.
Hi all, my name is Miss Lisa. Now I will tell you a little about benefit, challenges, and maintenance in earthworks. There are the benefit in earthwork, which are site clearance before building construction, road construction, railways construction and others. Other than that, earthwork can prepare the site or path before the construction and can launch the development process in an area that has been explored. Now we go to the earthworks challenges. There are 5 challenges that facing by the team when do the earthwork process in construction, which are transportation equipment, environment disasters, labor skill, soil or site condition and unrealistic expectation. The challenges of equipment always facing by the team because the earthwork equipment from the warehouse to the site cannot be operated directly because it can damage the road and took a long time to transport. Other than that, the cost of transportation also high. And the other challenges that facing by the team was this works can cause the environment disaster if it cannot be controlled, such as landslide, soil erosion and deforestation. The other challenges that facing by the team are the soil or site condition due to the shape of the earth surface, such as hilly ground, rocky ground and the muddy ground. The skills of the workers are very much needed in this situation so that the work runs smoothly. Finally, unrealistic expectations such as ground or site condition, labor skill and equipment condition. All these problems always facing by the team when do this work and sometimes causing accident that lead to the unwanted tragedies. There are 2 types of maintenance in earthworks, which are site maintenance and the machinery and equipment maintenance. Site maintenance must be carried out continuously from the first year of operation. One can expect the following troubles with dikes, such as slop failure, soil slip notch and slight erosion of the slope. Slight erosion in most of the cases IJ causes by precipitation and its trickling down the slope. Shoulders must be constructed on the slope and new horizontal layers must be compacted onto the top. Soil slip is caused frequently by bad quality of compacting, drenching of the dike or quick water discharge. The soil had to be replaced with well compacted horizontal layers of earth and possibly with a retaining wall. Slope breakthrough is caused by the same things as soil slip. For reconstruction of such a failure, first of all a footwall should be constructed, then a good quality earth material should be filled and compacted in thin layers. Slumping is generally caused by a lack of proper compacting of the dike. For maintenance, putting a new layer of earth on the top of the dike. There are 3 types earth-moving equipment maintenance in earthworks. Firstly, clean the earth-moving machinery regularly. A great way to keep earth-moving equipment safe is to clean it, because this type equipment has to do difficult and dirty work which can alter the performance of the machine. Train workers to operate earth-moving equipment. They must know how to use this equipment in order to avoid accidents that can damage the equipment and can cause injury to its users. Finally, take care of the earth-moving equipment properly. Improperly maintained machinery and heavy equipment can endanger its operator, as it cannot be difficult to operate and causes accidents to occur.
We have already seen 4 subtopics about earthworks process in construction. Now we go to the last subtopic that I will present, which is standard. This is the standard that must be adhered by the contractor to do a work in Malaysia. there are 3 components in this standard, which are general requirement, then standard and code of practice, and finally contractor responsibility. Thank you for the attention you have given during this period. Now, I want to hand over this task to my friend. Thank you.
Hi, Assalamualaikum everyone. My name is Nurul Aqilah. I will proceed to the next topic, which is safety and health in earthwork construction. First, I will present about excavation safety training. So, let's begin. Before starting any excavation, your supervisor will take a work permit for necessary areas that are to be excavated. This will ascertain the presence of underground utilities, and if they are present, then such utilities are properly isolated. This permit is given by the section in charge, and it a clearance to start excavation, and the corresponding safety precautions to be taken. Based on the work permit, your supervisor will instruct you take one or more of the following precautions. It's depending on site conditions. Locating underground utilities using markers and drawings. Locating utilities using advanced equipment and such cable avoidance tools. Making trial dips to check the presence of utilities and others. Isolating the services. Your job is to follow the instruction of the supervisor carefully while doing excavation. Do not forget to use isolated tools and tackle during excavation to prevent accident contact with power lines. Still, if you come across any symptom of presence of utilities, immediately stop the work and report to your supervisor. Now, I will move to our next video, which is excavation in construction or trenching safety. So, let's start. Employers must follow OSHA rules to protect workers in trenches. However, here the employer did not follow OSHA's rules, which leads to these workers losing their lives. Let's go over the main points of OSHA's rules for trenchers to see how to keep workers safe. All trenches must follow OSHA's rules. 1 cubic yard of soil can weigh as much as a car, nearly 3,000 pounds. So, unless the trench is caved-in, must be used for all trenches more than 5 feet deep, or for any trench that shows sign of caving. Before workers can do any work in a trench, a competent person must conduct an inspection to identify and remove any potential hazard. A competent person is someone who can recognize hazard in the area and who has authority to take good action to eliminate hazard, which may include temporarily stopping the work. Inspection must be performed at the start of every shift after a rainstorm or a condition change. The competent person must also test the soil in a trench. OSHA required at least one test by looking at the soil and at least one test by hand. If the person knows the soil types, they can pick the right protective system to keep workers safe when they're in the trenches. OSHA classifies soil in a trench as stable rock, type A, type B, or type C soil. Stable rock is safest soil for a trench. Type A is the next most stable, and then type B. And finally, type C soil is the least stable. It's important to remember that trench can have different types of soil based on the depth and climate condition. The competent person can choose from different protective systems for a trench based on the type of soil found. For all trenches deeper than 5 feet deep or for any trench that shows sign of caving, OSHA required sloping, patching, shoring or shielding to protect workers from caving. Sloping protect workers by cutting back the side of the trench so the side slant away from the trench. OSHA rules identify the degree of slope allowed for each different soil types. When trenches are less than 20 feet deep, these are the basic maximum allowable slope of each soil type. Stable rock can be vertical walls but cannot be undercut. For Type B soil, OSHA required that the walls be sloped 1 foot out for every 1 foot of trench depth. For Type C soil, OSHA required that the walls be sloped 18 inches out for every 1 foot of trench depth. It's important to note that this kind of sloping can only be used for trenches less than 20 feet. Any deeper and the protection must be designed by a registered professional engineer. So now let's look at the workers in the original scene who were stuck in the trench as it started to cave in. But this time the soil has been classified as the Type B. The trench has been properly sloped and the spoil pile is moved away from the edge of the trench. The trench walls are not caving in and the workers are safe while they work. Now let's review the shoring type of protective system for trench workers. Shoring uses various support systems to prevent soil and trench walls from moving. There are different kinds of shoring systems, but timber, aluminium, hydraulic are the two basic types. Aluminium hydraulic cylinders are the most common types of shoring. They are typically using spot bracing, plywood, and stucco method. To install the shoring correctly, you must first determine the soil type. The type of soil and the depth and the width of the trench determine the maximum vertical and horizontal spacing used with the members of the shoring system. If we use our example of 3 foot wide, 10 foot deep, 40 foot long trench in type of B, the shoring system we install will need to include 12 strong aluminium vertical shoes with 6 on each side of the trench. These shoes, also called rails, will be connected by hydraulic cylinder every 8 feet along the length of the trench. A hand pump pressurizes the hydraulic cylinder until they fit tightly within the rails. Now the shoring in place, let's look again at the workers in the trench at the beginning of the video. As before, the workers are laying a sewer pipe into the bottom of trench, but now the shoring system prevents the trench walls from caving, keeps the workers safe. Sloping and shorings are ways to protect the side of trench so they don't cave in. Shading is to protect the workers when they're inside the trench. Shading involves using trench work, also known as trench shield, or other supports to protect workers inside a trench from collapsing soil if a cave-in occurs. The competent person should pick a trench work that is right for the soil type and other site conditions. The trench work has 2 large plates which held apart for horizontal cross member. This plate or shield must be between the sides of the trench and the work area. The shields are strong enough to protect workers inside from a soil collapse. The shields can be 2 feet above the bottom of the trench as long as they can support the entire depth of the trench. There is no caving under the behind the shield. The top of shield should extend at least 18 inches above the level of any material that could cave in into the trench. Trench box typically used in open area, but they can also open with the sloping method. So let's see how a trench box could save workers from we saw the beginning of the video. For our example, we will assume that the workers are in trench with type of C and no sloping, but workers inside a trench box. This time, workers lay the sewer pipe into the bottom of the trench. They are protected from any possible caving. This example shows the importance of employers following OSHA excavation standards to ensure the workers are provided with safe workplace. So now I will proceed to our next video, which is key consideration in sustainable construction. Excavation means dust control and minimizing truck time for debris removal, setting up stockpile areas to recycle excavated earth or for backfill grading and topsoil. In setting up the work site, isolate potential damage to adjacent habitats and properties. The foundation is primarily concerned with moisture control. This includes the proper installation of drainage, inward groundwater and vapor barriers and other systems to keep the building dry. The framing process, whether for concrete or steel, required careful coordination of safety and scheduling. The idea is to be as efficient as possible to minimize waste, noise, and other environmental impacts. Proofing in the application of the waterproof membrane seal the building from rain and moisture penetration. Installation usually involve high VOC chemicals that improve risk to workers and the environment, so extra caution needs to be taken. The shield of the building includes insulation and out-elevation of the roof and walls. Insulation is embedded in the structure of the roof, and walls outside out-elevation is a relative surface on either siding of the roof itself. Other materials include high-efficiency glazing and generally sealing the building from weather penetration. Important as that as building is sealed, space big is attract VOC, dust, smoke, and moisture generated during construction of the inside of the building. In other words, once sealed, the building becomes an unsupported and ventilated indoor